Okay, this is one of the more challenging lectures for doing from home with this little tiny blackboard. But so last time we were talking about what is the pH scale, and I said it stands for the proportion of hydrogen ions in concentration. And I had written up on the board an equation about water. And the equation was showing that water will produce a proportion of hydrogen ions in water. And I said, it can and does this. It can and does do that, but it's very rarely. And so in order to sort of explore the pH scale, I'm going to ask a series of questions about how concentrated are the hydrogen ions in pure water. And so if I was to say, we had said that the pH scale is a 10-fold scale. Every step in the scale is a 10 times difference. So if I was to say that that this maybe happens 1 out of every 10 water molecules, if that was the case, we would say it was 1 in 10. We could write it in scientific notation, which is this weird notation where we go 1 times 10 to the negative 1. Or what does that mean? It just means 0.1% of the time, right? But it doesn't happen that much. And so we've said, well, with a logarithmic scale, like the pH scale, the next step would be 1 in 100, right? And we would write that scientifically. We would write it 1 times 10 to the negative 2. And what does that mean? It would mean it would be 0.01 or 1/100th. It doesn't happen that often, though. What about 1 in 1,000? 1 times 10 to the negative 3, 0.001. Doesn't happen that often. 1 in 10,000, I think you're getting the idea here, right? 1 times 10 to the negative 4, and you could write it like that. As you're writing these, 1 times 10 to the negative 5, doesn't happen that often either. That's 1 in 100,000. Still doesn't happen that often. It actually happens this often right here. 1 in every 10 million water molecules, 1 times 10 to the negative 7, or like you could write it out like this. Now, after a while, at first, that's not that cumbersome, 0.1, 0.01. But when you start getting all these zeros, it gets really hard. You say, well, is that 6 or is that 7 zeros there? You have to count and you have to be careful. So you can use scientific notation, 1 times 10 to the negative 7, and so you automatically know it's 6 zeros and a 1. And so it's just showing that. So when we talk about, if we were to convert this to a pH, we had said the pH is the negative, it's a negative of the log 1 times 10 to the negative 7. Negative times a negative is what? It's a positive, right? And it's the concentration. So if we change that exponent from a negative 7 to a positive, because by definition the pH scale is the negative log, it becomes a positive. And basically we figured out that's how pure water has a pH of 7, neutral. You might have known that. You might know that water is neutral, and what that means is this is the amount of hydrogen ions in pure water that's always there, because we just said that it breaks apart at this rate. 1 in every 10 million water molecules will dissociate like that. So it ends up, if you add, so we'd said, what do acids do? They release even more hydrogen ions. So if you have acid added to water, you're going to increase, right? You're going to increase the number of hydrogen ions. And so we said we have this kind of a concentration here, which is pH 7. If you made it 10 times greater by adding acid, and it went from 1 in 10 million hydrogen ions to 1 in 1 million, what would your pH be? It'd be 6. And then if you keep adding more acid, pH 5, and so on and so on. So you reach a point where you said you've added so much acid to that water that 1 in 10 of the hydrogens found in that water are hydrogen ions. That would be pH of 1, right? I hope you're following me. Now, what if you said, get rid of the water? It's all acid. It's all hydrogen ions. So there would be no dilution. It would just be 0. It would be 1 times 10 to the nothing, because there would be no dilution. It would be pure acid. Pure acid has a pH of 0. So, and it starts with the natural acidity of water, neutral, actually has some acid in it. 1 in 10 million molecules are acid, are hydrogen ions, and acidity is a measure of how many hydrogen ions are in concentration. What is the concentration of hydrogen ions? Okay, so from 7 to 0, it's a inverse scale. So the smaller the number, the higher the concentration of acid. What about the other way? We have bases, and I didn't talk about them much yet, so I'm going to stop here and we'll talk about bases and come back, okay?